Kia ora and welcome everyone to today's webinar. I will open with a karakia for our session. Mauri ora, kia mātou, arahina mātou ia mātou mahi. Ki mihia he huarahi mō te kaupapa o te mātauranga hangarau, a whina atu, a whina mai, te pau e here nei ia mātou. Hui e, tae ki e. It is my pleasure to introduce today's presenter, Jack, a truly inspiring and multi-talented educator, engineer, and innovator. Jack is an electronics engineer, software engineer, inventor, professional photographer, tech startup founder, teacher, and mentor. He's also proudly neurodivergent with ADHD, autism, dyslexia, auditory processing disorder, and global aphantasia, or as he likes to call himself, a neurodivergent overachiever. Jack has a deep love of learning and an equally deep understanding of how challenging that can be sometimes. That empathy fuels his passion for helping others who learn differently and for creating innovative ways to make technology and engineering accessible, creative, and fun. From designing a weather station on Mount Cook to developing library self-check machines, Jack's projects reflects his endless curiosity and his ingenuity. His current passion is JackBord, a platform empowering young people to get hands-on with electronics and coding, unlocking their creativity and confidence through technology. The impact JackBord is having on students' lives is already remarkable, and today Jack is going to share more about that journey and where it's heading to next. So please welcome Jack.
Hi.
Hurrah! Welcome.
It's all working. I was going to say, that guy sounds really cool.
That's you, Jack. That's
I want to
you.
meet him.
Over to you.
Yeah, absolutely. So, first of all, how many people are there and how many of you guys are teachers? Is that something I can
We
ask now? Can there
are,
like some
yeah.
way they can communicate
Let's
that?
have a look. We do have participants in the. We have participants.
That's good.
Yep.
Hey, how many of you guys are teachers and how many of you have like a neurodiverse kid in your class?
Please, if we could have answers in the Q&A while they're
Yeah.
putting in
So
there.
I've got to make a bit of a not a disclaimer. It's more like I was telling these guys before. So basically, yesterday I had my autism assessment from 9:30 to 12 o'clock in the morning. And that's part of the diagnosis process for autism. And my original plan was that I was going to do that. Then I was going to see the interns in the afternoon, et cetera, et cetera. And then this morning and this afternoon, I was going to prepare all the slides for my talk today because that's what I was going to do. That was my plan. But funnily enough, my autism, which is still quite new to me, decided actually no, we are going to sleep all of today, and we are not going to be doing any of that. And so essentially, and this is part of the whole coming out of autism, is that you get all this new stuff popping up that wasn't there before. So I've done some slides, don't worry, it'd be really cool. But again, it was just, and this applies to children as well. Like when they get diagnosed and when they start to experience all of this stuff, there's a lot of new stuff and it just happens. And so for me, I am incredibly hyperactive, like ridiculously hyperactive. If I'm sleeping all day, I'm either dead or I've come out of surgery. Either way, call the coroner. And so for me to actually just be floored for the day, like I literally had to pull myself out of bed so that I could get ready. Um, that's very new for me. And so that was really interesting. So I'm a little bit late on that. But the whole purpose of my talk is why it is so great to be neurodivergent. He says after after that. So first of all, this is my brain. It's an MRI scan that was done at the Otago University, basically. And in fact, there's an even nicer version of this, which is this one here. Wait a minute. This guy. So this is also my brain.
So
Looks
Jack,
normal.
we can't see that one. Do you want to
Oh,
share?
am I not? I'm sharing. I was sharing before. I love Zoom so much. Now can you see it?
There we go. I can see the
So can you
3D
guys see
circling
anything?
one.
Oh, okay. So this is
Yeah.
basically my brain. It's a brain scan that they did at Otago University. So go back to my slide. So you guys can still see that now? Ah, sorry, no.
Yes, all good, all good.
Okay, cool. So inside this lovely, colorful brain is ADHD, which is attention deficit hyperactivity disorder, autism, dyslexia, APD, which is auditory processing disorder, global aphantasia, and severely dysfunctional autobiographical memory. It's kind of, I think when they made me, they thought, hell, we'll just give them everything. You know, why do we want to stop at one? That would be just too easy. So the first one is attention deficit hyperactivity disorder. I kind of hate the name because it couldn't be any more wrong if it tried. Because for a start, I don't have a deficit in attention. I can concentrate when I'm in hyperfocus longer than any neurotypical person, like literally longer than anybody. On the other hand, I don't always have control over that. So it's not that I have a deficit, I actually have way too much. Hyperactivity is fine. Disorder, it's not really a disorder, it's just the way I am. Um, it's literally a neurodevelopmental condition. You don't have any choice. It's there and it's always been there and it will always be there. And it affects things like being able to pay attention. Impulse control is a big one, which can also be really, really good. Energy regulation, so being able to control energy. And essentially, it's just the way that our brains work is different. The wiring is different, especially executive function. And that's whereby for a normal person, you might think, oh, I'm going to go and jump over this railway line. And then the executive part of your brain will say, well, actually, you know, maybe that's not such a good idea. Maybe you don't want to do that. Whereas with attention deficit disorder, the connection between the let's do this really funny thing or this thing, and maybe that's not such a good idea is not so good. So by the time the executive department gets in there and decides this is not a good idea, I'm already on the other side of the track. And that can be very interesting. And also fast thinking. Like my brain literally never stops. There is never a time when my brain isn't doing something, and it just goes like a train. And that's actually one of the diagnostic criteria is it's as if you're driven by a motor, which can both be good but also bad. High energy and creativity, a lot of the creativity comes from the fact that number one, you've got a brain that's just going all the time. Number two, you don't have the normal inhibitions that most people have. And that's really, really important. And you'll see that later on. Difficulty focusing and sitting still. At school, I was always getting told off for moving. Like literally, you see it in my school reports. If only he would stay still, if only he would do this, if only he would do that. And that's just a part of who you are. And so teachers telling you not to move is actually really bad because I can't help it. I have to move. If I don't move, the amount of energy that you have to put into not moving consumes all the energy you've got for doing your schoolwork. So that was fun. Impulsivity is a big one, and then easily distracted. Like we see everything. So when you're sitting in a room like a library, you might see the book that's in front of you, and you'll be concentrating on that. Whereas I will see the book in front of me, I will see all the people around me, anything that moves. I will hear everything. So I don't just zoom in, I literally hear everything. And that makes it incredibly difficult. And there are three types of ADHD. Inattentive, which is you basically just are a bit of a daydreamer, you have problems paying attention, but you're not hyperactive. You're not constantly moving, running around the place. And in a way, this is probably, I suppose, in many ways, the worst one to have because this is the kind of kid that will sit at the back of the classroom and basically daydream the whole time and no one notices because they're not causing trouble. Whereas the second type is hyperactive. So that's where you've got a child might be physically very, very active, always running around the place, but they might not have the inattentive problem. So they might be able to concentrate really fine, but their bodies are just going for it all the time. And then finally, you've got combined, which is what I have. And that's where you've got everything's hyperactive. So my brain is hyperactive, my body is hyperactive, and they're just always moving. But that also makes me very, very creative. It makes me very energetic, hyper-focus, impulsive, time blind. And I see the world very, very differently. So just to get out of this and go to this one. So part of that seeing the world differently is this is me as a third-year engineering student, electronic engineering student at Canterbury University. And I started my own company. And this is my company. This was GPSC. These are all meant to be in the slides, but I didn't get quite around to doing it. And so I'm a third-year engineering student. I have started my own company, and we actually got a $100,000 contract with the Electricity Corporation of New Zealand to put a weather station 2 kilometers up Mount Cook. And that was a third-year electronics engineering student. I don't think they would have known that. I'm sure they didn't know I was a third-year electronics engineering student. And why this is important is, first of all, with ADHD and neurodiversity, you don't see all the reasons why you shouldn't do something. Most sane people would have never, ever done this. Just no. But we don't see those limits. And that's really important, because if you don't have the people that can just do stuff and not get caught up in all the no's, then you don't progress as much. The other thing is, it becomes more a case of you can't do this, or this is really hard. And for me, that is, how do I make it work? Like, I don't think of you can't do this. I think of how am I going to do this? And that, again, is really, really important. And that comes down to the creativity side. You don't take no for an answer. You are constantly looking at, how can I do this thing? How can I go to the end of it? And so this kind of comes out like here. So Jack can work when he feels like it. Yesterday, he wrote a story in 5 minutes because I wouldn't allow him to see a film. So a lot of the thing with ADHD is we need motivation. We are constantly chasing dopamine. And so how that works is that if something isn't new or novel, like having to write an essay, then it really can be very, very hard for us to do it, because it's just not interesting. Whereas you have something that's really, really interesting, and we will quite happily work for days doing that one thing. And that's the same with autism. So it's very much interest-based. This is one of my school reports, and it's like, Jack's language is good, but he must learn to respect other people's right to speak. So the ADHD impulsivity is, you'll get a kid who will suddenly blurt out an answer or just be talking all the time. And it takes them ages to write one sentence. So this is another thing. Writing can be very difficult, especially when you're neurodiverse. Another one of my favorites is fresh new teacher. He spends most of his time dreaming and secretly playing with some junk or another, and won't work if I take his junk away from him. So basically, again, because I was always very kinesthetic, I was always playing with things. One classic story that I have from boarding school is that apparently we were coming home, going to boarding school on the bus, and I saw this really big old valve TV by the side of the road, and I managed to convince the bus driver to bring this big television back to school. I was about 10 years old. And I remember that at the school, they just basically put me in the music room with a screwdriver and a set of tools and this big TV, and just let me go for it. And that was fantastic, because it was hands-on and I could actually just do what I wanted to do. Can everybody still hear me? Like, everything's fine? So I can't tell if anybody's even
Yes, you're
there.
all good.
Okay, good. I was like, it's so weird just talking to a screen. It's
But
bizarre.
I can put my face on, so it feels like you're
Thank you.
talking to someone.
And then if I'm boring people and they're dropping off, you can just tell me.
No, you're good.
Yeah, it's weird. Okay. So that's my ADHD. So the other one is my autism. My autism, I have had it my entire life. It has always been there, but literally, it's only in the beginning of this year that I began to realize it was there. And this is something that you will find in a lot of kids, especially today. whereby you'll have a child that might have been diagnosed with ADHD, and they'll appear to just be ADHD, but then they'll start on medication. And what the medication does is exactly what it did in my case, is that a change in my medication essentially got my ADHD under control a lot better. And then all of a sudden my autism started coming to the surface in a big way. And so the thing about autism is that it's a spectrum, quite a wide spectrum, and it has some characteristics of ADHD, but it also has some very distinct characteristics. And one of them is things like social interaction, different communication styles, and sensory processing. So the way that we process information. So for example, for me, sound is a really big deal. I find it very difficult to be in noisy environments because my hearing is very sensitive and I hear the sound very, very intensely. Also, if I'm in a place where there's a lot of people and I'm trying to talk with one person, it's very difficult for me to filter out everything else that's going on around me. So for a child in the classroom, if there's a lot of noise going on around them, for them to be able to focus on the teacher or to focus on what they're doing, it's so much harder because you've just got to deal with all this extra information coming in. And yet, on the other hand, the good thing about it is deep focus. So this is a very, very common trace of autism. And what it is you have a special interest. So for mine was always electronics, coding, spacecraft. We will learn about our special subject often to the point whereby you're literally an expert on it. The depth of knowledge that we can absorb on that subject is so deep that it goes way, way beyond what a normal person would bother to learn about. The flip side of that is that if something that we're doing, say in class, is not related to our special subject or our special interest, we don't want to do it. It's boring and it's really hard to stop doing it. We got routines and structure, heightened sensitivity to sounds, literal thinking. So a classic one. One time my Form 7 physics teacher said in class, oh, okay, shampoo is just soap. And so, of course, me being me, I spent the next month washing my hair with nothing but soap. And I can tell you right now, shampoo is actually not soap. It really isn't. It was terrible. So we tend to take things very literally, and that can cause problems because then you'll say something to me and I will completely interpret it in a different way that you never even dreamed of. And that can be quite challenging because then I'm doing the thing that I think you told me to do, but in actual fact, and you've assumed that I've received that and that I'm doing this thing that you want me to do, but I'm not, but you think I am. But again, very, very creative, very structured, very detail oriented. So I will see details and things that other people miss. People with autism tend to be very good at cryptography and at intelligence gathering because we see details and see patterns that most other people don't see. And that's actually really valuable. The next one that I've got is dyslexia. So again, that's interesting because, and this is what stopped me from doing engineering, you flip numbers around. So in my case, I flip numbers around, I flip words around, I will flip dates. I'll think something that's going to happen like tomorrow. It actually happened yesterday, but you get them mixed up. Another one is when I started out in school, I would actually write all my numbers backwards. I still don't know how I managed to do that, but that's part of dyslexia. And so essentially, again, all of these things that are apparently deficits also tend to make you very creative. So long story short, I went through college. No one knew that I was ADHD. No one knew that I was dyslexic, that I had autism, that I had auditory processing disorder. And yet I was smart enough that I would try and I would build up these compensating strategies to get through until eventually I got to university. I thought, great, this is fantastic. I'm in university now doing a Bachelor of Electronics Engineering, which is what I'd always wanted to do. And so at the end of my first year, I failed every single subject. There was nothing left to fail. I failed the whole lot. And I didn't know why, because I had no idea I was ADHD and I didn't know what was going on. And so my flatmates at the time, this is literally what happened. We're in the car and Time had done a magazine article about ADD, and there was a checklist in there of 10 points. And basically, by the time they got to number 8, they're like, you need to go and see the doctor now. And this is 30 years ago, back in 1994. And so I did. And he was like, yep, you're ADHD, big time. And so essentially, I started on medication. The university gave me a separate study room. So I had a desk at the master's office. I had my medication. I did all my exams in a separate room. I did fewer subjects. I had a reader writer. I had extra time. And the next year, I passed everything. And so you would have thought, oh, yes. So he got his Bachelor of Electronics Engineering. But actually, he didn't. Because what happened was that I realized that because of my dyslexia, maths was always hard for me. But when you have the numbers in your head and they jump around, that makes it pretty difficult to do maths because it's just a big old moving target. So literally, in my last year of engineering, I was putting weather stations on Mount Cook. I was hiring a professor from the chemistry department at the university to design me a snow pillow so that we could measure how much snow there was on Mount Cook. And yet I couldn't do maths for the hell of it. I just couldn't do maths. So I eventually changed to political science, and it's 4:23 because I'm looking at the time. Does anybody have any questions?
No, you're okay. I think you
Okay.
keep going. You've got plenty
Everyone's
of
still
time.
alive. I'm not killing anybody.
Everyone's still in there listening away for
Happy,
sure.
good.
We had one comment in there saying that they're neurodiverse themselves, so I think they're here to listen in to what you've got to
Hello,
say, and
brother.
they're primary trained and have taught many
Oh,
neurodivergent
good.
kids over the years. Yeah.
Excellent. So essentially, I ended up doing political science, international relations. And the reason I did that was number one, it relied on the fact that I could talk. So I'm a good talker. And in fact, you look at, there is actually a letter that I'm going to show you guys because it's actually pretty cool. This is actually really funny. So this is a letter that my mother wrote on the 20th of March, 1979. You're gonna love this actually. And essentially it said, so I had 18 months with weekly sessions with a child psychologist, and they concluded that I was brain damaged. I was like, he's got brain damage. And they put me on dexamphetamine, which is actually a stimulant medication that's for the treatment of ADHD. So back in like 1977, I think it was, they actually started treating what was wrong with me, but they had no idea, so they took me off it. But anyway, they said, where is it? Highly intelligent, overactive child whose achievement is way far below his potential. And then he said, he is highly articulate with a wide and sophisticated vocabulary, has impressive powers of reasoning, which means I would just argue the tits off anything. And I did. And a high degree of inventiveness and manual dexterity. And yet, I've abandoned any pretense of participating in school lessons. I have, at my present age of 6 in 5 months, I can read only a few simple words, and I have no conception of basic arithmetical functions. That didn't really change. And so, like even back then, they were literally like, "Okay, we can't do anything with this kid. He's got brain damage. We'll give him some drugs, but then we'll take them away because they work." Go figure. And that's through my report. So like you'll have kids in your class whereby on the one hand, they seem to be really, really intelligent, really, really articulate. But on the other hand, trying to get any kind of work out of them, or it's just so inconsistent, it just drives you up the wall. So what happened with me is that I then married a Singaporean, because why would you marry a Kiwi? Marry a Singaporean and move to Singapore. And so fast forwarding, coming to the JackBord experience, and I'll come back to the auditory processing in a minute. I was at Paparuma College in 2015, and we wanted to start a robotics club. And Victoria University gave us about 30 Raspberry Pis, which are those little board computers. And they were really good, but the problem was that you needed a screen, a keyboard, and a mouse. You needed a power supply. They were really easy to break. You couldn't just plug motors straight onto them. You had to go through a whole elaborate process to do it. And it just struck me that they were really annoying. And so what I started doing was thinking about how can I change that? How can I actually make something that will make it easy for kids to do robotics? And robotics is essentially the culmination. It's the culmination of software, electronics, sensors, control. It's all lumped into one thing. So long story short, the end result was this. I didn't call it the JackBord. Guru, who was a member faculty at the time, came into my workshop one day and said, "What are you working on?" And I said, "I'm working on the Hammy board because I needed a name for this thing." And I asked my youngest son and I said, "What should I call this?" And he said, "Hammy." And I was like, "Okay, fine, Hammy it is." And then he said, "No, you're not. You're working on the JackBord." And I'm like, "What? No, I'm not. I'm working on a Hammy board." And that's how it got the name JackBord. So the first thing about this is that it's all aluminium because I'm clumsy. So I drop things all the time. So it had to be strong. It has a built-in power supply, so you don't need an external power supply. And you can see inside, which you've just got to be able to see inside stuff because otherwise it's just one more black box. You can plug motors straight in. So for example, down here, I have wait a minute. So this is a laser robot that basically drives around and it has a laser rangefinder on the front and it will measure the distance to the wall and it will navigate around a room. The motors bolt straight on. So that was another thing that was really important for me was that you had to be able to bolt things on. Whereas normally you've got to go through a whole drama to fit the motors and so forth. And the motors just plug straight in. So it was how do I make things very, very simple and yet not trivial? So it actually has to be able to do stuff. And also basically make it jack-proof because I'm dyslexic and I always get the wires, when you plug in the wires to things, I always get them around the wrong way. And that's annoying, especially like with a lot of the sensors from AliExpress, you put them in the wrong way and then you get this really pungent smell coming out of it. And all of a sudden you've got no more sensor. So I made everything so that any kid can put the wires in any way around they want and they're not going to blow it up. That was really important. And then the other thing is that you can turn them into just about anything. So this guy here actually measures the soil moisture for a plant. So I'm pretending to be a plant. And so it uses a survey. So literally it just shows you what the soil moisture is. And again, it's simple to make and flexible. Because that's the other thing about the fact that I'm ADHD. I never know what I'm going to want to do the next day. And so I designed the JackBord so that it doesn't know what you're going to want to do, but chances are you'll be able to do it because I've already put all the stuff in there for it. And that was a really big challenge because how do you make something as open and flexible as possible and yet make it achievable? And so these guys are really, really good, but they're quite expensive. So another part of what I do is it's really important that people can learn. And also it's important that we don't have barriers. So a lot of what I do is getting rid of barriers. And so, of course, having to need a screen was a barrier. So with these, you just use the Wi-Fi and you use it on your Chromebook. Having to have an external power supply was a barrier, so got rid of that, et cetera, et cetera. And so the basic, which is this guy here, this deals with the cost barrier.
Hey, Jack, do you
Yeah.
want to stop sharing your screen so we can see it bigger?
Oh,
Like, yeah,
sorry.
that would be
Yeah.
really good because then we can see a little bit more detail in it.
Yeah. Okay. No, stop sharing. Oh, there, stop share. Okay, how's that?
Yeah,
Is that
cool.
right?
We can see you. Oh, yeah, now we can see the detail.
Okay,
Should
sorry.
be cool. No, you're good.
Uh, I hate Zoom so much. I swear to God. So this is the JackBord itself. And, yeah, so this is the unit, the first unit that we designed, that I designed.
Mm.
And again, it's all aluminium. You can see inside because I wanted kids to be able to see what's actually going on inside as well. You can drop it. like I drop these all the time and they survive. The pin layouts are all the same for each of the ports because again, memory is important for me as my memory is terrible. And so I made it so that it's easy for the kids to know what to do, because if you can use one set of pins, then you can use all of them. And then this is again, this illustrates the whole point of like, you should just be able to connect stuff and just have it work. So the motors, this is a universal motor bracket. And you can put 5 different type of motors can bolt onto this thing. Because again, I got sick of, you have different motors and then how do you mount them? It's a pain. So this can mount pretty much anything. And this guy has a laser rangefinder on the front and he literally drives around. And when he comes up against a wall, he'll go back, random turn, and then go somewhere else because he doesn't want to be around the wall. And it's all self-contained, nuts and bolts to bolt stuff together. So we have Jack Harno, which makes it easier for the kids to build lots of different things. And I'll show you this in a minute because I just remembered I got a whole bunch of cool pictures. And this guy is the soil moisture meter. So basically it's just a dial with a servo motor. This is a light stick. So it's got RGB LEDs on it. And again, I'm pretending to be a plant. So right now I'm dead. I don't want to be dead. Okay, now I'm happy. And it's really easy to build. So what is important about this particular example is that you've got a completely self-contained instrument that kids can take around the school. You don't have to have a Chromebook with it or a PC or anything like that. And then when you're done with it, you turn it into something else. So it's not just that kind of thing.
Super cool. We've got a question
Good.
saying they're enjoying your presentation. If
Thank
they're
you.
teaching a year 4 to 6 class, say 20 kids, what would you recommend buying to start off?
For year 4 to 6,
Yeah, and say 20 kids. Like,
I would say something for JackBord, this is probably going to be a bit much for them, but just in general, something kinesthetic. The movement is more important than the actual complexity of it, as it were. Actually, that's one thing we do. I teach year 6, 7s, and 8s. And so another thing that I designed, this is called the top, and this has just got electronic components on it and some buttons and variable resistors. And so the cool thing about this is I'll start my kids off with this and they start making simple circuits. So they get LEDs going, they get transistors going, they know how to use buttons and variable resistors without the PC. That's the beauty of it. So it's literally all hands on, everything they need is right here. And then after they've learned this side, you literally bolt it onto the basic. And what that does is all of a sudden the stuff that they were controlling here with just the buttons, they can then start controlling with programming. So essentially something that, first of all, lets kids build something that's easy and then extend it by letting them control it. Does that answer the question? Yeah.
yeah, I guess so.
And that was like, this was one of the barriers. So these are like $70 each. And they run off a Chromebook. You don't need Wi-Fi for them because it gets the power and the Wi-Fi from the Chromebook itself. And it's just great. Like it has built-in knobs and buttons so they can turn it into a game controller so they can make graphics games and things like that. If you put this one on, you get an extra 2 buttons and 2 variable resistors. And one of my students made a CAD program. He literally designed a drawing program that used all the buttons and knobs to control the cursor and to put different shapes and so forth. And again, that was just so cool. So again, this is about removing barriers. Give them lots and lots of ways of doing things, and then they'll be able to do it. And the other cool thing is that you can use this to drive like this guy. So you can literally use these ones to drive these ones. And again, that was really important. Like, why shouldn't you be able to do that? And that goes back to my neurodiversity. For so many people, it's like, why should you be able to do that? Why should you be able to do this? Whereas for me, it's like, why shouldn't you be able to do that? But that's my thing is why can't you do that? Why shouldn't you be able to do that? And then that's a huge, big difference. I'll show you some other things that I've done. Let me show you some pictures of what the students have done. Again, I apologize for this being a little less organized, but it's just the whole, oh, I've got to share my screen as well. So good like that. I love Zoom.
It's the whole
I think
being
it's,
ADHD and autistic
oh,
thing, right? Yeah.
it really is. And especially as I mean, ADHD I've been doing for quite a long time, but the
Yeah.
autism thing is very new. Let me get into here. And these will give you some ideas as to what we've done. And I love this so much. Okay, wait a minute. Here. So first of all, beach cleaning robot. Yeehaw. This is Nemo, the beach cleaning robot. This is one of the early JackBords. So it literally had 5 JackBords in it that would run it. It's built on top of an old mobility scooter. This is it working. So the claw is there. There's a JackBord controlling the claw. There's another one controlling the actuators.
Oh, that's
That
incredible.
was so cool. This is my senior students. And we would take this out to primary schools to do outreach. And so, like, these were the very early JackBords, and the kids would build all this stuff. It's incredible. And this is one of the initial claws. And this, okay, so this is actually a hammy board. This is what came before the JackBord. This was when I was trying to figure out how, like, I was going to do the ports. So these are the ports, which correspond to these ones here. Like, how was I going to do that? How was I going to make it easy? So I would come up with different variations, and then I would let my kids loose on them, and they would try it out. And if it worked, it was worked. If it didn't, it didn't. And then this is one of the arms, the robot arm that they made. They did all the electronics themselves. So I think that's another really important thing that we don't do these days is we don't let kids get messy, get dirty, blow stuff up, make mistakes. Like they did all of this by hand, and I know they destroyed at least 2 of these before they got it right, but they learned so much. And then this is literally the number of JackBords. So we had them doing the navigation for the GPS and the compass, controlling the robot arms. There was even one inside that actually ran the mobility scooter, and that was really cool. Another one is Raspberry Pi Shake. So at Te Kura Mario Porirua, we entered the Massey University Crisis Lab competition, and the kids had to come up with an alert device for an earthquake. And this was ours. It had the warriors inside the canoe, inside the waka, all the LEDs. We won. They actually won the best alerting device section, and this was the very first time they'd ever done it. And this is the actual day. So they create the earthquake, the warriors poke up, the lights go off, the sound. And so you had 5 or 4 or 5 different JackBords all doing different things. And this was the first time ever that everything had worked at the same time correctly. And that was amazing. And these guys had never done any of this. We literally had this is on the dashboard. So they were plotting the live data from the seismometer as it came in. And that was amazing. Yeah, so doing data plotting, which again is something that kids should be able to do easily, is plot data from sensors and so forth. So that was really cool. This is Baxter, and the whole idea of this robot is that it uses robot vision to shoot ping pong balls at anything that comes near it that's red. Because who doesn't need a robot that shoots ping pong balls at things that are red? And again, you'll see down here, you've got a couple of basics. So one of the basics is controlling the drive motors, and then another one is controlling the shooter. The stream monitoring project. So this is a project we do with Kapiti Primary School, and this is using the JackBord basics here. And they're actually measuring turbidity, which is how dirty water is or how clear it is, and water temperature. And these are primary school kids. So these are years like 7s and 8s. And that was a lot of fun. And because it's really easy to get the equipment out there and use it, you don't have to worry a whole bunch about expensive equipment and getting it wet and whether it's going to get damaged. And then the other thing we did is we used a JackBord itself to do data logging. So they're digging the trench to fit the sensors that actually went in the water and stayed there for months. And then the JackBord was literally underneath a drain cover, a manhole cover. And this thing would sit in the water and it was just collect the data. And then I was talking about getting messy earlier. What happened here is that for some reason the sensors stopped, and so they literally pulled it out of the water and they started like taking it apart to figure out what was going on. So it wasn't like, oh, this is broken, we can't use it. It was like, this is broken, we need to open it up and fix it. And that's what they did. And this is some of the data. This is temperature and light collected over a number of months. And again, this is more temperature and light. And so they're collecting real data and actually learning how to do science. This is a driverless vehicle that the seniors did at college, again, with the JackBords. And this is the robot vision for it. And so we actually had, that's the chassis there. And some of the computing gear was all in the back. Wait a minute. Yeah, and so this is the mayor of Kapiti, and it was literally driving him around autonomously. And we actually called it the, God, what did we call it? Oh, Elon Mustang. This was the Elon Mustang. Oh, it's 42 minutes. Am I going too long?
No, you're good. We've got up to an hour. We do have
Okay.
another question that's come in.
Yeah, cool.
So thanks, Jack, again. I think
Sorry.
everyone's enjoying it. It's good.
I hope
What do
so.
you recommend for kura with low budgets? Because they'd be nervous about things breaking and not being
Yeah,
able to buy
but
replacement
something
bits.
like this one here.
Yeah, right. Yeah.
Simply because A, it's $70. B, it's designed for people to put the main way you're going to break it is by either physically smashing it, in which case, you're on your own. But the other one is like getting the wires in the wrong place. But because these are designed so that if you do put the wires in the wrong place, you're not going to break it. So that's really important. And then the other cool thing about these is if you like short circuit the power supply and so forth, it protects itself. So it will protect itself rather than cook itself. And that's really, really important as well. So yeah, absolutely
Awesome.
something like this.
What's next for JackBord, do you think?
So the next thing for JackBord is we have an amazing new dashboard, which we're working on right now. And we've got some interns from Victoria University working on it as well. And the whole point of that is to streamline the way that the kids interact with it. So if I show you right now, because the other new thing for JackBord is the learning system, which I wrote. And basically, so again, I wanted a system that was very, very simple for kids to be able to access learning materials online. But it also needed to be something that I could use as well. And so, for example, if I go to here, one thing you'll notice is that the lessons are very simple. There is no periphery stuff going on. And then if we click into a lesson, it's all page-based. So that's the first thing. Everything comes in distinct pages. And I also include some history. Like all lessons have history, because I think, again, part of what makes some of the stuff boring today is that you just jump straight into the lesson rather than the history, rather than pointing out the fact that this simple frequency counter here that you could buy today for $50 when it was made cost as much as a house, that kind of thing. Then how jumper wires work. Like really just taking them through step by step, which was important. And so part of what we're doing in terms of the future of JackBord is enhancing this whole area of how do we deliver learning material in such a way that it works really well for neurodiverse kids, because if it works really well for them, it works even better for everybody else.
Yeah, fair comment.
And
And
that's
of course, we've
a
got a
big deal.
new curriculum coming out, which will have
Yay.
electronics and
Yeah.
robotic mechatronics in there. And how
Yeah.
well is this stuff going to fit? It's going to be so
It'll
good.
fit perfectly. It'll be
Yeah.
really, really good.
Have you thought
I'm
about renting, putting, like renting out kits for
I
short?
like that idea. I like
Yeah.
it a lot. And I think that's something we're going to need to look at for sure. But even beyond that, you can actually start using the JackBords themselves, the virtual JackBoard, and you don't need to buy anything. Like you literally just go to the dashboards. If I do that now, also I have to choose an account. So you have the physical JackBord, which is this guy, and then you have the virtual JackBord, which is an online version. So if I just choose one of these profiles, I'm going to start up a virtual. And I get in there. So this is the dashboard. So if you see all of these little dots along the top here, can you see that all right?
Yeah. All good.
So these are equivalent to that pin there. So these are port A. So these pins are all equivalent to port A. So I can literally control those pins from the virtual, and I can turn them on and off. So you can do hardware stuff from the command line. A quick example is if I just go random. Oh, did I mention I can't spell? So the whole point of this virtual system is it lets kids that don't have any hardware be able to do stuff. And that's really, really important. So I'm going to run the random circle generator because I just love that so much.
Hey, look, I've just had a comment say that'd be awesome. I know lots who would want to rent the kits.
Yeah,
So there you
that's
go.
good. I would love
New
to do that.
business model for you.
Yeah, I think so. Uh, get that out. See, this is one of the annoying things about the current dashboard is that if you search for something and then you change page, you lose it. So this generates random circles. And again, this is actually really important. So I run it and it will literally start creating random circles. So that seems trivial, but what it means is that kids can start writing games. They can start doing things with graphics without any hardware. And so the next point is like I get my year eights to start using these buttons and so forth on the basic to change the direction of the circles, make them bigger, make them smaller, change the colors, all that kind of stuff. And the actual programming language is very simple. I wrote that myself. It's called Octagon. And again, it's very, very clear, like random, make a random number, put it into there. And it uses the same commands that are on the command line. So the kids will start off on the command line with just the top and the basic, learn how to turn things on and off. They'll be doing something really cool. They'll fill up the command line and reach the end, but they'll still want to do the thing that they're working on. And so that's when you get them into programming, because all of a sudden, this command line is stopping me from doing something. I want to learn programming because I want to do this thing, rather than you need to learn programming because it's good for you. I should stop talking. Questions.
No, I've been bringing the questions
No
up as they've
questions?
been, yeah, as they've
Oh,
been coming
wow.
through. Yeah.
Um, yeah, so the whole point for me is number one, getting rid of barriers.
Mm.
Number two, making sure that no matter whether a kid is rich, poor, whether they're in a school that doesn't do technology at all, or they're in the middle of a farm, they should be able to do this stuff. Your condition as a child, whether you're in the middle of nowhere or in a good school, shouldn't impact you being able to do this kind of thing. And that's why there's so much learning material on the website to make sure that we can supply that. Whereas often with things like the Raspberry Pis, they're absolutely amazing, but to find information, you often have to Google it, which means that you really need to have an existing level of knowledge, and it can be quite daunting. I have never managed to figure out why people think Python is a good language to learn as your first language, especially if you're neurodiverse. I mean, give me a break. The whole indent thing in the spaces just drives me out the wall. It's kind of sad. Like, I think we lose a lot of students in software because the first thing they come into contact with is Python. And if you're neurodiverse, it's painful. It can actually be really, really confusing, whereas it doesn't have to be. Um, yeah, I think I'm running out of brain power.
No, that's okay.
If
I'm
there are
happy for you
questions,
to
I'd be
run out
really
of,
happy.
yeah, we'll see if there's any more questions. But in the
Yeah,
meantime, I just love all those, the hands-on learning of the
yeah,
making the robotics and out in the
yeah,
local curriculum and the rivers and
yeah,
like looking at your science kits and stuff. There's so much
mm,
possibility.
yeah. And
Yeah,
I love that.
and inclusivity, like
Yes.
being able to include
Yeah,
our neurodiverse learners,
yeah,
or putting them first. You've come up
yeah.
with a really good solution here.
Mm.
And you haven't got bored of it, Jack.
No, which is incredible. It really is. And that's the thing. It's like I don't get bored of this because it's always changing. And that again is a really important thing for engaging neurodiverse kids, especially the ADHD ones, is we love change. We love variety. We thrive on that. The irony is that I'm also autistic, or I am also autistic, and autistic kids don't like change. We don't like variety. We want structure. And so for the kids like me that have got autism on one side and ADHD on the other side, they're often fighting it out because ADHD wants to do one thing and autism wants to do something else. So that's also very interesting. That's a whole new talk right there.
Yeah.
But yeah, it's And probably the single most important takeaway from this whole thing is that it is the neurodiverse kids that will change the world. Steve Jobs, Leonardo da Vinci,
Absolutely.
Bill Clinton, Elon Musk, for better or for worse. It's the guys that don't think normally are the ones that change things. That isn't to say that neurotypical people aren't cool. They are, because Lord knows if it was only neurodiverse people, this planet would have like gone years ago. But to actually cherish the people that see things differently, that will approach a problem differently, that don't accept what's normal, that don't just take this the status quo. That is so important, and yet we have a tendency to squander those kids. We find them too difficult, too much effort. Government doesn't want to put the funding in, and yet they're the ones that will come up with the thing that has the huge impact that changes way more than anything else. And that's just incredible. Like, damn it, New Zealand split the atom.
Yeah, absolutely. We're the most creative, innovative.
Country in the world.
Yeah,
Yeah.
we are, and those are the students we are producing.
Yep.
We've got two comments here. One from Ruth. Kia ora, Jack. Ngā mihi nui. Nā mō te kōrero e tēnei rā. Can I ask if you're considering te reo Māori for your online
Yes,
courses?
I would love. I actually teach at Te Kura Māori o Porirua in
Oh,
Porirua,
awesome. Mm.
and I would love to do that.
I know
I
someone who
really
could
would.
help you with this, so
That
we
would be
can,
great.
yeah, I can connect
Yeah.
you. And Olivia said, this is awesome. I teach in an all girls school, high school, and this seems like a great option for bringing some excitement into tech for them,
Yeah.
as we have a low amount of girls wanting to do tech at the school currently, both
Oh, that'd be great.
neurodiverse and
Yeah.
otherwise. And I think that can be some of the issue with our digital technologies courses where we get stuck on computer screens with
Yes. Yeah.
game design and website
Mm,
design, and they seem to be the only
exactly.
two topics, and yet we could
Yeah.
be really broadening our
Oh, yeah.
horizons and getting out there and linking them to
Mm.
real contexts. Can I just get you to stop sharing
Sure.
your
Yeah.
screen? I'm
Absolutely.
just going to put up a slide to
Mm,
for people to share feedback, but you can
yeah.
continue
Um, yeah. What I was going to
chatting.
say is, I always get my kids to start off with hands-on. I
Yeah,
don't get them to start off on the screen, and that's really good because there are definitely a lot of kids that if you just put them straight into the software side, they're not going to do it. Like they're going to hate it. But if they start off with this and then they're doing the commands, and all of a sudden they need to get into the software side because they want to finish the thing that they've started, that's a much, much better way, at least in my experience, of getting them to do it, because all of a sudden they're doing it because they need to, not because it's like Brussels sprouts and they're really good for you and you have to eat them.
yes, yeah, absolutely.
Yeah. And I
Right.
promise next time I'll have my slides
Oh
all
no, that
organized and it will be all beautiful and I won't sleep all day.
I think that is totally fine. Um,
Thank you so
okay,
much.
thank you. So you can everyone see, can you see that feedback slide?
Mhm.
Yeah, feedback slide. So there's a QR code there for feedback on today's webinar, and also to give us any ideas for new webinars, maybe another
Mm.
repeat one with Jack, especially around, yeah, electronics and mechatronics
Mm.
coming out in our
Yeah.
curriculum. We're going to need lots of support in that
Yeah.
area with
And
teachers.
dialoguing,
Yeah,
getting more kids doing
absolutely.
science, but actual uh, real science, like deep science, where they're actually collecting data sets and being able to do things with the data sets
Yeah,
rather than just let's measure this for half an hour and then we'll forget about it.
yeah. Making those real world links, right?
Yeah, exactly. Yeah.
Yeah. And then you can also go to our ARCL platform to start a conversation or ask some questions
Mm.
around today's webinar. The next Wednesday webinar is with Craig Patterson from Capability Collective. He is going to be talking around literacy to fluency in AI for Kaiako. So he recently presented at our TENS conference, and it's kind of like the next workshop on from that. So look forward to that
Cool.
one in November. And yeah, thank you so much, Jack, today. It was
Thank you for having
incredible,
me.
and you can have a little rest now, and I will finish off with a
Thank you.
karakia for the day, and we will go well. He karakia whakamutunga. Kia mātou katoa. Kua mutu mātou I a mātou mahi, I a mātou kaupapa hoki, arahina mātou, kia kawe mātou I a mātou heipapa, kia whakatapua mātou ki ngā kaupapa me ngā mea e whakapono, manaaki tia mai mātou. Kia ora everyone.